Hey guys, it's been a while, but I'm finally back with a new post-processing script. And oh boy, this one gave me a hell of a headache. A while ago I made a script that deforms the infill to be non-planar in a sine wave form to hopefully increase the shear resistance of the z-axis. My new script is built onto that, but now it includes walls too, and it works in Prusaslicer, Orcaslicer and Bambustudio, instead of only in Prusaslicer. It also enables you to change the directions of features independently. But here comes the reason for the title of this video. I coded it so that you can enable that the sine wave alternates between wall loops. This results in an overlapping pattern and removes throughout clear breaking points on the layers. I'm not equipped to do testing myself, but it sure does feel stronger as you can see here. I think it's best to only make a slight deformation of about the height of a layer or two. I'm really looking forward for someone to test this with a more professional approach. Now let's look at how it works and what options you have to play around with. You are able to control a non-planar deformation in the form of a sine wave to both the infill and walls independently, and you can turn it off for the outer walls if you'd like to have a traditional looking print. You can control the direction, frequency and amplitude to be different for walls and infill. The deformation starts at the first solid layer and ends at the next solid layer, and fades between them. If there are multiple of them, it restarts and ends again. This happens globally for each layer, so if you have multiple islands, they affect each other. This is something I want to fix in a future update, so that it works island dependent. And there is a bug that yet needs to be fixed. If there is no top layer, it never stops, as you can see on the chimney of the Benji. Okay, now let's first look at all the parameters before we install it. Minus include infill, minus include parameters, minus include external parameters are here to enable different feature types to be processed. Minus infill amplitude, minus infill frequency, and minus wall amplitude and minus wall frequency are here to control the sine wave for both the walls and the infill. Minus infill direction and minus wall direction are here to control the direction to apply the deformation. Minus max step size is used to control the maximal amplitude increase per layer. Minus alternate loops is used to turn on the alternating sine wave per layer loop. Now let's install it. For that you need to have Python installed, which you can download from python.org. Then open a command window and type var python and copy that path. Download my script from the GitHub, which is linked in the description. Now in Prusaslicer, go to print settings and then output options. And now add your path to Python in quotation marks. After that, add the path to the script in quotation marks too. And then after that, you can add all of your desired parameters behind the script. Keep in mind that your nozzle can collide with stuff and don't overdo it. You also need to disable arc fitting and BG code, otherwise it won't work. If it doesn't run, try to start the slicer in administrator mode. Now you can hit slice, and the script will run on export. To view the results, you need to look at it again in the G-code viewer. Now, one different thing to mention. Funny enough, after my first video about the non-planar infill only, someone actually reached out to me and told me that he made his master thesis about a similar subject on non-planar deformed infill for the use in drones. And it includes some promising testing results. You can find it in the description, it's really worth a read. And who knows, we might be able to join forces in future. Now, one last thing to say is a huge thank you to all my supporters, especially after my SSD accident. You really helped me out a lot there. Thank you for watching, leave a like and comment if you want to support this video. Now I wish you a happy Easter and as always, have fun printing. Goodbye!